Hello, welcome back. So in this little video tutorial, we'll see how to implement a two-dimensional cellular automaton. Again, we'll be using Excel, just like before, a spreadsheet, just like for the one-dimensional cellular automaton, and in fact it won't be much harder than that. So if you haven't seen the video on the one-dimensional cellular automaton, you should actually go back and watch that first and also do these steps for yourself on your own computer, and you'll have a much better understanding afterwards, and you'll definitely be ready to tackle this one. Let me give you an example of how we could run into trouble with a spreadsheet. Let's assume all that I want is really a single cell, make it this one here, that starts with the value 1 and then increments itself, goes to 2, goes to 3, goes to 4, and so on and so forth. I mean, this is pretty similar to what we're trying to do in the cellular automaton. The cells take a new state. Doesn't matter whether we do something simple as just incrementing a number by 1 or whether we're doing something much more complex. We want this cell to take a new state. Now, normally, adding 1 I would do by a formula. So we say equal this cell itself, which is E14, plus 1. And there's trouble already. Excel cannot calculate this formula. Why not? Well, it calls it a circular reference. So this cell E14 says I want to be E14, the value in E14 plus 1. I want to be my own value plus 1. But of course that can't be, right? I can't be my own value and at the same time my own value plus 1. That's not going to work too well. But this is essentially what we're trying to do. So let's try that a little bit differently. We just reset E14 to be, say, the number 1. And we say, well, the follow-up value we actually calculate in another cell. We'll just take one here, 2 to the right, and that is E14 plus 1. Well, of course, easy. That'll work, right? But now, how do we get that value back in here? Well, we could say this is the value of this cell, which we calculated as the new value, and we just copy that over here. This is the value of G14. Whoops, same thing. Now again, we've got a cycle. E14 says, I want to be G14. G14 says, but I want to be E14 plus 1. So there's no way that that can be resolved. But all of this is really only because Excel is trying to keep the whole spreadsheet consistent. We can make our lives much simpler by telling Excel to only go through one evaluation from the left to the right, top to the bottom, for each cell, and not worry about making everything consistent again. So the way we do this is by going into the preferences of Excel, up here. We choose calculation, and you see here it says calculation is normally automatic. That means do everything to make the spreadsheet consistent. But that's what we don't want. We say do a manual calculation and only use a single iteration. Only use this once. Calculate all the formulas once and then don't do anything else. Let's see what happens now. I still got a circular reference. This is referencing I want to be G14, and this is referencing I want to be E14 plus 1. But it doesn't complain anymore. And if I now trigger a single evaluation, and I can do that by pressing function 9, F9. So I do this now, function 9, 3, 4. Next time, the 4 will get copied into E14, G14 will copy to E14, and then G14 will add 1 to that, 4, 5. So in this way, I can actually achieve what I want. I have my original cell here, and I have a copy here that does the new calculation, and then I just copy the value back. Okay. So we need to set our spreadsheet to manual evaluation, calculation, manual, use iterative calculation, and only one iteration. And when we've done that, we can update the cells in much the way that we're thinking about it. So to make your life a little bit easier, we've prepared a template here for you that you can get from your teacher. And really all that's different from a blank kind of spreadsheet is that you can here in this cell select restart or run. And when you select restart, the iteration down here will be reset to 0. So it's already set to manual calculation. Let's check that. Preferences, calculation, you see here manual, do only a single iteration. And so if we use F9, then with restart function 9, it will always go to 0. And if here I pick run, then with every evaluation, the iteration will be incremented by 1. I'm pressing again and again and again. And we will use that to solve this problem of breaking the circles, the cycles in the references, but you'll see how exactly later. Reset. And don't look at this down here below. Don't touch it, because that's only needed for this here above. If you change it, things might go wrong, so just don't touch that. What we'll be playing in here is up here, this space. Okay, so let's get started. So the very first thing that we need to define is our initial state. So let's do that. And to make sure that we get something that's easy to test, let's just take a pattern where we know how it propagates. So the glider, for example, sounds like fun. Let's do that. Okay, so let's define a glider. If you can't remember what that looks like, let's just find one on the web again quickly, or you can of course go back to the notes. Game of Life glider in Google should do the trick. There it is, right, and even tells you straight away how it propagates. So let's just put that one in. Which one do we like? I'll take this one here, time step 1. So we've got to need to make this a bit smaller to be able to see that. Or maybe I'll just start with time step 2. It doesn't matter because it goes in circles anyway. So we've got a 1 here, we've got a 1 here, we've got a 1 here, we've got a 1 above that, and we've got a 1 above that. And that's all there is to it. So we can fill the other cells with zeros. Let's say we'll just make this small because we only want to check whether things work in principle. So I'll copy that over. And maybe actually I should put these cells a little bit higher so that there's more room to glide. So I'll take these again, paste them in a little bit higher, fill the rest down there with zeros. And this I need to fill manually so that I don't override the ones. Okay, so that's my glider there, just like defined here. Get that out of the way. But maybe it wasn't actually such a good idea to do that on the board, because remember, the board later needs to take the follow-up state, so we probably need to keep the initial state somewhere else. So I'll copy that to a separate sheet here in this workbook. So I generate a new worksheet down here. I shall rename that straight away. Let's call that initial or start state. I go and I copy all those cells from here, cut, paste them into this spreadsheet instead. And we'll look later how we use that to generate the initial state of this board over here. Okay, so now we want to calculate the new state, the follow-up state of each cell, and you will remember that what the follow-up state is depends on the state of the cell itself, but then also on the number of neighbors. So the most fundamental thing that we need to get is the number of neighbors that are alive, as in signified by ones. And to do that, to count that, I generate a new spreadsheet. I will call that, whoops, not up there, I will call that count. And as usual, we just do that for a single cell first. Let's say we take C4. So C4 will simply be the sum of everything from B3 to D5, but not here. That's important in the spreadsheet board. So we type in sum, opening bracket, go to the spreadsheet board. For C4, it's everything from B3 to D5. Closing bracket up here. But then the important part is this includes the cell itself. So I need to subtract that again, minus the cell itself, board D4. Board D4. So that's a 0 at this point. Let's see whether that works. I'll put a 1 in here. Put a 1 in here. So now the number of neighbors should be 2. Let's calculate. We've got manual calculation, so function 9. Yes, that's a 2. Now let's check that my own state, being C4, doesn't matter. So I put a 1 in there. Go back to the count, press calculate, F9. Whoops, it has changed. Now that's not good. What have we done wrong? Let's look closely at the formula. Sum board B3 to D5 minus the center cell on board. Oh, but we've subtracted D4 here and not C4, which is what we wanted to subtract. So let's change that. Minus board C4. Let's check again. This should have 2 live neighbors now. If that's a 0, go to count. F9 works. Now what went wrong before was if we had a 1 in there, go to count, recalculate with F9. Now everything's all right. Good. So we now take this cell and copy it to the whole board, and we wanted the whole board to go from this corner to G8, just for a tiny test board. Calculate just to check it, F9. Seems to work in almost all places, but not here. In the first column and the first row. And you remember this problem from the one-dimensional automaton. It's the boundaries, right? The sum here is looking at all the surrounding cells, but to the left there is nowhere here, and to the top there's nowhere there either. So it can't calculate that formula. So let's just fill that with fixed values. Let's say 1s. Sorry, I should have said let's say 0s, because that's what I did. Okay, let's check that again. I go back to the board, I delete my 1s here. It should all go to 0 now. Let me recalculate. Function 9. It's all 0. So that seems to work. So I've got my initial, I've got my counts, and now I just need to calculate the follow-up state. And of course, you may have expected that. To calculate the follow-up state, I again take a new spreadsheet. I'll rename that into, let's call it new state. And so what each of the cells in this will do is it looks at the count as well as its current state on the board, right? So one way to be alive in the next generation was if you've got exactly 3 neighbors that are alive, then you're definitely alive. Either you survive or you're born. Those were the ideal conditions. So let's note that down here. This is not a calculation, just write that down for us to remember. If count equals 3, we are alive, right? The other possibility is if the number of my neighbors that are alive are 2, if count equals 2, and I'm alive, right? Then I will also be alive in the next state. Okay, so let's try to translate that into formulas. So let's take again C3. So the first one is very simple. To make a decision in Excel, you write a formula and you take the decision operation, which is called an if, like in most other programming languages. So if you want to have a look at that, click on it, brings up the documentation. It's a logical test, and what it says, you have got a condition here, and if that condition, the spreadsheet will check that as true, then you're getting the first value as the result, and if it's not true, you're getting the second value. So let's use that. So we define that for C3. We use the if, opening bracket for the condition. We want to check whether the cell C3 on the spreadsheet count. Let's switch to count. Count C3 is 3. That's the condition, a comma. Now comes the value, what if that's true? I want a 1 in that value, and if it's not true, I want another comma. I want the value 0. Closing bracket, enter. Good, so we've defined that follow-up, that part of the follow-up for the cell C3. But that was only the first condition here. If I've got 3 living neighbors, I'm definitely alive. If the count around me is 3, then I get a 1, which is alive, otherwise I get a 0, which is dead. Now I need the second part. Now the second part, let's just illustrate that in another cell here, is if my count is 2 and I'm alive myself. Let's write that in this cell here. And we'll combine it later. If, my problem is now I have 2 conditions. If my count is 2, well, we know how to write that test. So we go to the spreadsheet count, and we were in D4 this time. If count D4 equals 2. So we had that before, but now I have another part, and I'm alive. So I combine that with an and what I want is that I'm alive myself. That means on the cell, on the sheet board, I need to have a 1, right? And board D4 equals 1. Then I want to have a 1, otherwise I want to have a 0. Now that's not quite how Excel wants that, because it doesn't like that and in the middle. Instead of writing it in the middle, you need to write it in the front, before the 2 conditions, as a function, and then an opening bracket, the first condition, count d4 equals 2, then a comma, and the second condition, board d4 equals 1, and a closing bracket. And this is exactly the same, but the end isn't in the middle. You can't express it that way. You need to express it like a function. Okay, but now we still got one problem. We've got two different conditions here. This is the second part that we had here. If the count around me is 2 and I'm alive, then I will be alive. And this in the other cell, C3, is the first part. If the count around me is 3, then I'm alive. I'm a 1, otherwise I'm a 0. We need to combine these two, right? So we do exactly the same as we've done with the AND. We take that condition here, I copy it, and I say, go to the other cell, I want that as an OR, as an alternative, behind my first condition. Of course, now I need to adjust the references here. The count is now for C3, not D4 anymore. And so is the state on board. Okay, but just as before, I cannot write the OR in the middle. I need to write it before. So I take the OR from here, I write it in the front. First condition, count C3 equals 3, then a comma. Second condition is the one with the end. And then I need to close my bracket down here. Okay, now I've got the right condition there. Either my own count is 3, then I will always be alive. That was that one, dealt with. Or my own count is 2, but my own state on the board is 1, in which case I will also be alive. In any case, this condition is true, so that I get a 1. And if that's not true, I get the alternative value here, the 0. So we're done with that. This we've just used to develop this, so we delete that. And now the usual thing, we need to take that cell and copy it to all the other cells, from B2 to avoid the boundaries to G8. Copy it in, fill the boundaries manually, done. We don't need this down here anymore, that was just a note to self. Okay, so we're pretty much done, right? We have an initial state defined here, we've got the count defined in this spreadsheet, and we've got the new state based on the count. Currently it's all pretty boring because our board is 0, so whatever we evaluate empty, which is the same as 0, whatever we evaluate will just end up as zeros. Let's see whether anything happens really. Let's just put some 1s in for starters. Whoops, not 11s, just 1s. And let's evaluate. Do the counts go up? Function 9. Yes, the counts have changed, obviously. And I also got some new states, which is 1 in a column, and you might have expected that because when you've seen the game of life, you know this was a 1 in a row, or this was a row, a bar in a row. That translates, toggles into a column that we see here, so everything seems to be going well. So the last thing that we need to do is we need to fix up our board. Let's get rid of these 1s again. And now this whole stuff that we've set up for you down here comes in really handy. Because when we've got the first iteration, we want to copy over from the initial sheet. When we've got any other one, we actually want to copy over from the new state. By now you've seen that we can have decision operations with the if, so we shall use that. And to figure out what to do, we just look at the value of the iteration cell down here. Let's do that. We write in A1, if the iteration is 0, so we go to that cell, B12 is 0, then we want the value of A1 in the initial sheet. Initial. So you may see that that cell is blocked here. That seems to be a bug in the current version of Excel. You can get rid of that by just toggling to another sheet and toggling back to initial. It's a bit annoying, but unfortunately can't do anything about it. So it's all good now. I can click into initial A1. Okay, so if iteration count is 0, I want to copy A1 from the initial sheet. Otherwise, comma, now we're in the other value, I want to copy A1 from new state. New state, A1. Closing bracket, and we're done. Okay. Well, we're not done quite, but almost, because remember, from what we've seen already when we did the one-dimensional cellular automata, if I take this cell and I copy it to the other cells, let's copy it over there for starters, all the references to other cells shift in the same way, right? And you see that makes sense. It's in B2, so I want to copy from initial B2, or I want to copy from new state B2. Now that makes a lot of sense, but unfortunately it's also shifted the reference to the iteration. The iteration counter here is at B12 down here, but it's shifted that to C13, and that wasn't meant to happen. You may remember what helps against that. If we put $signs in the references, it will never shift it at all. So we say $B12 instead of B12. And we take that and we can now copy it, same place, and you see the B12 is still the same reference. So we can now safely take that and copy it everywhere else, up to, let's say, G8. So the final thing that we might want to do is we might want to apply the conditional formatting again to make that a little bit more lively. Let's say we apply conditional formatting by highlighting value 0 and 1 as before. If the cell value is 0, we want it red. And again, second rule, conditional formatting, highlight cell rules equal to, if it's 1, we want it green. So that was exactly like what we did in the Sierpinski spreadsheet. Let's check whether that works. Put a 1 in there, it's green. Put a 0 in there, it's red. It works. So we copy that and just paste it with using paste special. Only this format to all the other cells. And at this point, we should be done. Right? So if we now press evaluate, what should happen is we're copying all the cells from the initial spreadsheet into this spreadsheet. Let's give that a shot. F9. Whoops, there's our glider. And now what we need to do is here, from restart, we switch that to run. And now the values will actually be copied from new state, but will get updated automatically as we've defined it. So let's see whether our glider glides. F9. And there, it's exactly the same as before, only translated one spot down. So, it works. Congratulations, you've just implemented the game of life for the first time, and as we've already told you, that's kind of a rite of passage. So, you've done that now. Maybe you want to make this spreadsheet much larger now, or give it some different and prettier colors. Anyway, good luck, thanks.